Okay, good morning, my dear students. I'm back with the integration. Okay, and integration, the new topic which we are going to see in the today's video, that is integration of rational functions of sine and cos x. So let me give you the introduction for this type. We'll be seeing such kind of case. Or maybe both. So we will be seeing these three forms. Isn't this a rational function? Because p by q form, and of sin x and cos x. So yes. So 1 upon a plus b sin x dx, 1 upon a plus b. Have I written the same? Wait. 1 upon a plus b cos x dx and 1 upon a sin x plus b cos x. So such type of forms we will be seeing and their integration regarding to that. So we'll be using the substitution method, and what substitution will do, I'll explain you in the question itself. Okay, before starting the questions, I just want you to recall the trigonometric formulas which I've written here. Sin x is 2 tan x by 2 upon 1 plus tan square x by 2. Cos x is 1 minus tan square x by 2, 1 plus tan square x by 2, and tan x can be written as 2 tan x by 2 upon 1 minus tan square x by 2. This formulas we have seen in the 11th class in the submultiple of trigonometric functions. That is sin 2 theta is 2 tan theta upon 1 plus tan square theta. So similarly sin x will be 2 tan x by 2 upon 1 plus tan square x by 2, and that is for cos and tan. Just keep in mind this thing because we will be going to use this only in the question. Okay, so this is the question. Let me explain you. Integration of dx upon 2 plus cos x. Now how to deal with this question? As we know, cos x is equal to, just right now I wrote 1 minus tan square x by 2 upon 1 plus tan square x by 2. Now let us consider tan x by 2 is equal to t. So this is the only thing. You have to think at some other level, and you have to just do this question. So in this question, what you have to remember, we need to use the trigonometric identity, and in that tan x by 2 we have to put as t. Now differentiate both the sides with respect to x. So tan x by 2 will be sec square x by 2 into 1 upon 2. Differentiation of x by 2 is 1 upon 2, dx is equal to dt. If you put tan x by 2 equal to t, then you just put here 1 minus t square upon 1 plus t square. So your cos x is 1 minus t square upon 1 plus t square. Keeping it aside, now this sec square x by 2, can we write 1 plus tan square x by 2 as identity? Take 2 to that side, dx is equal to 2 dt. Now again, in place of tan x by 2, you can put t, so 1 plus t square dx is equal to 2 dt, or your dx value is 2 dt upon 1 plus t square. So in this integral, you have the value of dx in terms of t, you have value of cos x also in terms of t. Just put both the things. So integration of dx is 2 dt upon 1 plus t square, and in the bracket 2 plus, in place of cos x we are putting 1 minus t square upon 1 plus t square. Now take the LCM. If you will take LCM, so it will be 2 plus 2t square plus 1 minus t square upon 1 plus t square. This 1 plus t square to 1 plus t square cancelled, and here you are left with 2 plus 1 3, and 2t square minus t square, you are left with t square, and 2 is out. 2 integration of dt upon this t square can be written as t the whole square plus this 3 can be written as root 3 the whole square. Now isn't this a identity of integration of dx upon a square plus x square, or x square plus a square, which is nothing but 1 upon a tan inverse x upon a plus c? So we have used the identity 2 into 1 upon a 1 upon root 3 tan inverse t upon root 3 plus c. Now the last thing is put the value of t which you have considered, that is tan x by 2 here. You will get the answer. So you know, such type of questions are only there in this form. If you have here sin x, then what you will do, this full step you have to repeat in each and every question. because you need to replace dx, no? So for that you have to repeat this step in each and every question. Say for example, if this question was of sin x, then your formula will change here, because as sin x is 2 tan x by 2 upon 1 plus tan square x by 2, so your sin x will become 2t upon 1 plus t square. So nothing will be, this step will be same, here also same, 2 plus, in place of 1 minus t square 2t will come, multiplying this here 2t. Okay, so let us do this only, we'll understand one more question from here. To integration of 2 plus 2t square plus 2, you can take 2 common, take 2 common and cancel with this 2. So the 2 will be cancelled, so I'm removing this 2 and I'm writing properly as t square plus t plus 1. Now you know how to integrate this, because this is a quadratic equation and we'll use completing the square method. What is that? We are seeing the coefficient of, first of all, this t. The coefficient of t is what? 1. Divided by 2, so 1 upon 2. Square it, so 1 upon 4. So we need to add 1 upon 4 and subtract 1 upon 4. Then what we will do? This and this term, we are taking close. And 1 minus 1 upon 4, you will get plus of 3 by 4. Now this is nothing but the square of 1 plus t plus half the whole square, and plus this can be written as root 3 upon 2 the whole square. Again you will use 1 upon x square plus a square identity in it, and you will get the final answer of it. Okay, so like this we do. Okay, so here is the question. Integration of cos x upon 3 cos x minus 5 dx. Now how to deal with this question? So what we are doing in this question, you just see what I'm doing. First of all, what I'm trying to do, I'm trying to make this denominator in the numerator. So for that I need to build up the numerator in this form, and why I'm doing so you'll get to know when I'll solve the question further. As with the cos x you have 3, so what I'm doing first, I'm multiplying by 3 in the numerator and dividing by 3 in the denominator. Okay, we have minus 5 in the denominator, so what I'm doing, subtracting minus 5 and adding plus of 5. Now separate this term with this term plus this term with this term. So you will get 1 plus integration of 5 upon 3 cos x minus 5 dx. Now is it easier for you to solve, because integration of this will be x upon 3 plus integration of this. Right now only I explained you the way. So can I just directly do, in place of dx, it will be, as I know, it is 2 dt upon 1 plus t square. You just solve it. Okay, and this 5, when it will be multiplied, it will give you 10, and here 3 into, in place of cos x I'm writing 1 minus t square upon 1 plus t square minus of 5, x upon 3 as it is, 10 dt upon on taking the, that is LCM, this 1 plus t square and this 1 plus t square will be getting cancelled. Multiply this 3 inside, so this will give you 3 minus 3t square minus 5 t square. Now on solving you will get one quadratic equation, or finally you will get in such a way where it will be easier for you to solve. So like that we have to do this question. You know, if such type of things comes, then you make the denominator same as that in numerator, and you will be reaching that step where it will be easier for you to solve. Okay, so in such type of question, have this mindset. Okay, like one more option I was thinking to put the direct values. cos x value is 1 minus t square upon 1 plus t square. This cos also 1 minus t square upon 1 plus t square, and this dx is 2 times of dt upon 1 plus t square. You just try to solve this putting all the values directly, and just show me what are you getting. Okay, if you solve after that step, then it is very good. I think that maybe there could be some challenging steps for you. So if you could solve, then it is really very nice, or else you can use this way, no problem in this. Okay, so the thing is, we are going to see the another category of such kind, that means the form which we studied today. No, we'll be seeing some other type of other category of it. So if you have the form like a sin x plus b cos x upon c sin x plus d cos x dx, I guess this only we can consider, right? Can we? Yeah, we can consider. So we have given the form some other special, that means we have given this form some other space in the, that means in this form which we are studying right now. So how to deal with such type of situations? Okay, so sometimes it would be like it would be tedious to make the denominator same as that of numerator, and like cancelling and separating. So we made a very like short trick for this. What we do, consider the numerator equal to L bracket the denominator plus m bracket derivative of differentiation of the denominator. When you will solve, compare the sine function with this a and the value of this lm, and compare the value of this cos x with this L and M. If you didn't understood what I've told all this thing, let us come to this question which we have done with the other way. So let us do with this way. As I told you, the numerator, let me write you in a very simple language. Numerator is equal to L bracket denominator plus M bracket derivative of denominator. I mean numerator, which is cos x, L into denominator, which is 3 cos x minus 5 plus so plus m bracket derivative of denominator. This is what will be the derivative of denominator? Will it be 3 minus of sin x? Because 3 cos x is what? Minus of sin x. Multiply this L. So 3L cos x minus 5L plus this will be minus of 3m sin x. So this will be our star equation. As I told you that after you differentiate, this next step will be your star equation. You give, because you need to put the values there, no? Putting the value of L and M here. Okay, so now if you compare the cos value, 3L is equal to 1 because this is 1 of cos x. So 3L equal to 1. Compare the value of sine function. So you don't have sine function here. So your minus of 3m is equal to 0. What is your L came? 1 upon 3. What is your m value? 0. Put the value of L and M in this star equation. So you will get cos x is equal to 3 cos x into 1 upon 3 minus 5 into 1 upon 3, and this will be 0. So finally what you got? 3 into cos x minus 5 upon 3 So in place of this cos x, we can write 1 upon 3 into 3 cos x minus 5 upon 3. Okay, and that is what we got in the previous question also. So that is how we will be going to use this form. Let us see one question of it. So here is the question: integration of 2 sin x plus 3 cos x upon 3 sin x plus 4 cos x dx. So as I told you, take numerator equal to L times of denominator plus m times of d dx of denominator. Okay, so multiply this L, this is as it is, plus derivative of this is 3 sin x will be 3 cos x and 4 cos x will be minus of 4 sin x. Multiply this L inside and this m inside, so you will get this and this. Now here this cos x and this cos x, take cos x common, so you will get 4L plus 3m, and in this one and in this one, these two, take sin x common, so you will get 3L minus of 4m, and that means the LHS which is going on. Now you compare the cos function, so you will get 4L plus 3m equal to 3, I have written here, and compare the sine functions, so you will get 3L minus 4m equal to 2. Now they two are the linear equation, so solving it, you know how to solve the linear equations. On solving, I'm getting m equal to 1 upon 25 and L equal to 18 upon 25. As I told you, this will be your star equation, because we need to put the value of L and m here so that we can write the numerator in this form. So let us write this 2 sin x plus 3 cos x as L, that is 18 upon 25 bracket 3 sin x plus 4 cos x plus m. In place of m will be 1 upon 25 3 cos x minus 4 sin x whole upon 3 sin x plus 4 cos x. Now you need to separate this term with this and this term also with this thing. Okay, so if you separate this with this, you will get 1 as an answer, and finally you are left with 18 upon 25 dx plus 1 upon 25 I'm keeping out. Inside the bracket you have 3 cos x minus 4 sin x whole upon 3 sin x plus 4 cos x. This can be solved as 18x upon 25 plus 1 upon 25. You know, if you consider this is equal to t, you will get this as your numerator. I'm trying to say, consider this 3 sin x plus 4 cos x is equal to t. Differentiate both the side with respect to x, so it will be 3 cos x, and this cos x is minus of sin x, so minus of sin x dx is equal to dt. So in place of whole you can write dt, in place of this you can write t. So what is the integration of 1 upon t dt? Log t. Okay, so log t, in place of t again you put this value. So finally I am writing you write these things, log of t, which we consider 3 sin x plus 4 cos x plus c. This is the final answer. Okay, so like this you have to do. So I hope you'll do this exercise, because only 4 into 8 questions are here. So first of all, go through all the examples and then do this exercise. Okay, in the next video we'll come up with the new topic, that is integration by partial fraction, which is very important topic for you to understand. So till that, do practice. Have a nice day. Enjoy your weekend. Thank you so much. Bye bye.